So the second fundamental theorem of calculus allows us to have a new way of writing functions. So in the past we would write a function like this. Let's just say 3x squared plus pi x plus blah 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 blah. So in the past this would be a normal standard way of writing a function, or a standard way of plotting, or a standard way of drawing a graph. But now this second fundamental theorem of calculus allows us to have a new way of writing a function, or allows us to have a new way of drawing a graph. Well, I can express this graph here as this, as an integral. So in the past we would use f of x equals, I don't know, 3x squared plus blah blah blah. Well, this here is a new way of expressing a function. It is a new way of us drawing a graph. It is possible for me to express a graph. I don't know what it looks like, but it is possible to have a way of expressing a graph in this form here, containing the integral. So we can express a graph in this form here. So for example, let's look at this. I've got a graph that looks like this. You see, this is a new way. The second fundamental theorem of calculus allows us to express a graph in this form here. So when given this, we can use the fundamental theorem of calculus 2 to jump from here. Well, when you differentiate this, it will give you this. But then the second fundamental theorem of calculus 2 allows us to jump from here to here. So it's simply the second fundamental theorem of calculus allows us to jump from here to here. So me expressing my function in this form here. So this is me expressing my function in this form here, but you have no idea what this looks like. So you have to use the second fundamental theorem of calculus to jump to this. So from this, you've got, from this you know what the derivative looks like. So we will go deeper into this in the next video, but just for the time being, just take my word that this thing here looks like this. Okay, so now this thing here looks like this, something like this. Okay, so I'm trying to express my function in this form here, but you have no idea what this looks like. But by using the fundamental theorem of calculus 2, you can jump to this, and then that you know that the derivative looks like this. So I'm trying to express a function in this form here, but really all that I've given you is the derivative. So this is a new way of expressing a function. This is a new way of expressing a graph, if you like. But then, in effect, in disguise, all that I've given you is that the derivative looks like this. The derivative looks like this. So a new way of expressing a graph is me expressing it in this form here. But really, all that I've given you is the derivative. All that I've given you is a derivative to work with. So I'm trying to express a graph here. But all that I've given you is that the derivative looks like this. So from the derivative we can build up a picture of what our original graph should look like. Okay, so the fundamental theorem of calculus 2 allows us a new way to express a function. It allows us a new way to express a graph, if you like. But all that I've given you to work with here is that the derivative looks like this. So it's a way of me giving you, it's a new way of me expressing what the graph will look like. But all that I've given you is the derivative to work with. Okay, so from the derivative you have to somehow build up the original function. I will elaborate more on it in the next video. Okay.